Good evening, everyone. I'm really excited to be here. I mean, I didn't expect this much big a crowd today evening. First, I would like to thank AWS, Daft, and Snowflake for organizing this wonderful meetup. Uh, today we'll be talking about Iceberg at Netflix. First, I would like to introduce us. So, I'm Snehal. I'm an engineering manager at Netflix for the Big Data Warehouse team.
I'm Brian. I'm a developer on the Big Data Warehouse team.
I'm Tim, also engineer in the data warehouse team.
Yeah, so my team is responsible for building and managing foundational services. We develop all the foundational services for managing the lifecycle of all the analytical tables in Iceberg table format. So these services are like the catalog, the maintenance table procedures, as well as optimization services like replication, compaction, etc. So for today's agenda, what I'll do is I'll first cover the business motivation of Iceberg at Netflix, and then cover some use cases of Iceberg usage at Netflix, and then go over some statistics to illustrate the scale of Netflix. Tim will go over the current architecture, and then finally Brian will talk about the future of Iceberg, of where we headed, and finally open up for some questions. Okay, business motivation. Yeah. So Netflix has always been a data-driven company, and we use data to inform our decisions. And Iceberg was invented in Netflix in 2017 because Apache Hive, which was at the time very popular, was not scaling for the growing business needs at Netflix. And then shortly after invention, it quickly caught fire because it solved a lot of the problems like consistency that Hive couldn't provide. And then in 2018, after the open sourcing of Iceberg, it caught fire not just at Netflix, even outside. So Iceberg at Netflix not just solve analytical use cases, but even the machine learning use cases. Our homepage is a perfect example of that. Our homepage is actually uniquely tailored to each and every member's personal taste. We use data to actually understand our member preferences. So the tiles that you see, the titles, the recommendations are actually tailored for the user. Even the thumbnails that actually show there are used, we tailor it to the taste of the user. Even the top 10 that we show in is actually powered by Iceberg. Some of the other use cases that Iceberg powers are the studio and creative production team uses. Basically, the team uses the script to actually do genre detection, genre and content categorization. The experimentation team uses Iceberg for A/B testing our homepage, where we do hundreds and thousands of experiments every day. The finance team actually uses Iceberg for billing and membership to actually accurately recognize the revenue. And then even for security, we use it for access logs, audit logging, and also fraud detection. And even the new verticals that Netflix is embarking in, like ads, live, and gaming, Iceberg powers all those use cases. Next, I would like to cover the scale of Iceberg at Netflix. So currently, the data warehouse at Netflix is over an exabyte across 3 million plus tables. We are at almost 99.5% adoption rate at Iceberg, with only 0.5% of remaining Hive tables that we currently have. We aim to be 100% of Iceberg next year, and once we are like at 100% Iceberg, we really want to actually, deprecate all the legacy stuff that we have, and we are really excited to get there as soon as fast. Next, our largest table of Iceberg is almost at 36 petabytes, and it works very well. We ingest about 10 petabytes of data every day, and we delete about 9 petabytes of data every day. We replicate 2 petabytes of data to a centralized region in US East 1. At our peak, we commit about 600 appends or whatever different operations to a table per second. And we do about 12K table load operations per second. This is probably not the largest installation out there. There might be bigger ones, but it serves Netflix use cases very well. Next, I would like to ask Tim to come over and talk about the current architecture.
Sure.
Thanks, Neho. First, I would like to introduce about a high-level data platform architecture. So from the left side, we have the online data stores and cache and other stores which produces data. And then come to the middle, we have Flink and Kafka and other tooling we have to really get data into our warehouse. And once it's landed into the warehouse side, we have a whole stack of tooling. On the top, it's UI and Tabular and other notebook and other tooling. And then coming down to query engines and APIs, data platform serves. And then it comes to the storage, Iceberg and Hive, and also the cataloging services and data protection engines we have. And then it comes down to the storage infra layer where we heavily rely on AWS S3 and also Hadoop clusters we run internally. And zoom in to Iceberg data flows a bit here. So really from the microservices and databases that produces data, we stream them in. There's also CDC cases, we capture the data from relational databases and bunch of custom tools different teams have built to really import the data into Iceberg. And once it lands on Iceberg, we have engines and tools that you can, various engines and tools you can use to interact with the tables. So we have query engines and lower level, like some teams use Java API directly, and wrap Python Iceberg also. So these are the major, some example of major query engines. So we have Spark for heavy lifting ETLs, and Trino for more interactive ad hoc queries. And if you want a more responsive, you can also ingest ingest data into Druid. And yeah, we have made it real easy to import data to Druid also. So next I will talk about the warehouse services we provide. So first is the data cleanup. So there's a snapshot and often files cleanup, the standard ones. At Netflix, we also provide a data TTL-based exploration where the users can define a column, and then usually it's a date column, and then the TTL then will calculate derive the filters of Iceberg and then apply that and delete data automatically. Then we also do optimizations like a compaction. Also, so there's also use case of moving data to a single region where when we ingest data from a streaming path like a Flink, we want data to land as soon as possible in the local regions. But eventually when it comes to query time, we don't want to cross a region, and that's slow and expensive. So we move the data into a single region with the data rewrites, and then it will be going from there. Queries will be much more faster. And next, I will cover a little bit about the cataloging. So this is our current architecture of catalog here. So we have a Metacat, which is an in-house service where we use as basically when engines or Iceberg clients need a commit, it talks to Metacat to do this the swap. And then also there's a Metacat serves as a legacy catalog for their Hive tables. So it's originally built on top of the Hive Metastore. But since we're moving toward Iceberg almost all the way, so we use our own database so that can be much simplified. So we are also exploring Iceberg REST catalog. Like early phase, we actually built one in-house, which we the Pi Iceberg already started using that. So that works out pretty well, at least for the basic loading table and doing basic commits. So next, I will touch on a little bit about security. So we've internally built a custom ACL-based authorization system, where at high level, basically, it's in the Iceberg Java library. At the time of loading a table, we send a request to our internal auth service. Once it's authorized, it checks against the ACO list. If you're in that list, then we will send out the token for the table prefix. Under the hood, it's basically a credential STS token for the S3 prefix. Yeah, so, and we manage the grants with the Trino SQL. It's pretty standard and easy to use. And then direct S3 file access to these buckets are blocked, so that you have to go through the authorization service. So that's how we protect the data. Yeah. Next, I will hand over to Brian.
Thanks, Tim. Yeah. So Tim just showed that Netflix has a very innovative and feature-rich data platform, but we do face some challenges. Some of our past priorities of the data platform are no longer our objectives. So, for example, supporting Hive, we add significant overhead, and we no longer need to support Hive. And also, many of our challenges are rooted in supporting these old objectives. So first, the Metacat catalog client has evolved to become very complex. It's really 2 catalog clients in one, supporting both Hive and Iceberg. A lot of logic lives in the client, so it's doing things like authentication, accessing data on the S3, manipulating the metadata, and producing events to Kafka. And having it perform many functions limits our ability to iterate quickly on features. So it's not trivial to keep the clients updated. And also adding so much functionality requires a lot of library dependencies that cause compatibility issues. Netflix was a pioneer in table maintenance processes along with Iceberg, but these can be hard to upgrade. So as mentioned by Tim, we have processes for compaction, janitoring, and optimization. These were all developed independently and use very different frameworks. And because there's little shared code between them, they each need to be enhanced independently. Also, they need to support both Hive and Iceberg. In addition, it's hard for us to keep Iceberg itself up to date. So Iceberg was created at Netflix, and we have many engineers with knowledge of the code base. We have a tendency to add what's needed internally and then adding to open source later, or sometimes never. Our internal fork has diverged from open source, which makes it difficult for us to upgrade to the latest version of Iceberg because those changes need to be ported over. And because we're running an older custom version, we can't use Iceberg features like branching, merge on read, and so forth until we do upgrade our Iceberg library. And running this older version also makes it more difficult for us to contribute to open source. Our reliance on Metacat and a custom file I/O makes it more difficult for us to integrate with third-party engines and tools. So with Spark, Trino, and Flink, we have our own forks that add in the Metacat support. This is additional code that needs to be maintained and also adds extra overhead when we want to update the engine versions. Using Metacat also makes it harder to integrate with third-party engines. So most engines don't support Metacat out of the box. So for open source engines, we need to fork them and add in the Metacat support. For other engines, we need some type of sync layer, which is often not very reliable. So this is a simplified diagram of what our warehouse system looks like now. This is similar to what Tim already showed. We have Spark, Trino, and Flink in our Kregel Python tool using Metacat directly. In addition, The client takes both, the client is talking to both the Metacat server as well as S3 and also producing events to Kafka. So a lot's going on there. In addition, the events produced are very different for different cases. There's no unified event architecture, and some of the clients don't produce events at all. We recently started supporting Apache Iceberg. Like Tim mentioned, it's using an Iceberg REST catalog. We didn't port over the Metacat catalog client. Instead, we went with the standard REST catalog client that's baked into Apache Iceberg. This IRC doesn't support the full IRC spec, and it relies on Metacat on the back end as the source of truth. A priority for our Metacat server was to support both Hive and Iceberg. So Metacat runs an embedded HMS, and Iceberg catalog information is stored both in a separate database as well as the HMS database itself. And Metacat also is reading from S3 to get the Iceberg metadata. Third-party engine support, it basically, like I mentioned, requires a sync layer. And this can be flaky and cause inconsistencies if one table sync succeeds and another one fails, for example. Also, to avoid further complexity, the engines are read-only for the Iceberg data. And then finally, the table maintenance processes, they're all very different and they're triggered in different ways. So our goals are to focus on Iceberg. We want to focus on Iceberg and drop support for Hive and other legacy systems. This opens the doors to many of the improvements we're targeting. It allows us to streamline the architecture, iterate faster, and so forth. We want to stay close to open source Iceberg, and this has many benefits for us. We can more easily update Iceberg to the latest version. We benefit from running the same battle-tested code as everybody else. We benefit from code reviews from the many Iceberg experts in the open source community. And we can't always control the Iceberg version that an engine is using, so staying close to open source should give us the broadest engine support. Next, we want to move to IRC as the source of truth. This gives us a consistent view of the metadata across engines and tools. It also gives us the ability to integrate with execution engines more seamlessly. Server-side metadata management allows us to ensure compatibility across different Iceberg client versions, and also we can enforce certain table properties and manipulate the metadata in other ways. We can also optimize the storage and retrieval of the metadata. With the IRC, we can centralize eventing and security, so rich events can be generated off of the commits and scan report server side. The events will be consistent across engines, tools, and versions. We can easily integrate on the eventing without requiring client updates or keeping client versions in sync. Also, credential vending happens server side, so that further simplifies the client. We want a unified event-driven architecture for our table maintenance processes, and we also want to enhance those table processes, like making our table optimization smarter and more automatic. So here's a simplified diagram of the direction that we're hoping to go. Here you see that the execution engines are all talking to the IRC via the standard REST catalog clients. All clients get a consistent view of the table and the metadata. This greatly simplifies our engine integration. It also opens the door for integrations that weren't possible before or were very limited in scope. IRC will be a full-blown IRC that implements the complete API. Metadata will be stored in an optimized way, transparent to the client. Events will be produced to Kafka from the IRC rather than the clients. And these events can include information from the commits and the scan reports reported to the IRC. And moving all this functionality from the client to the IRC allows us to iterate much more quickly, and it can provide features that users want in a more timely manner. We'll introduce a new maintenance control plane. This will consume the catalog events that the IRC produces and trigger maintenance processes. We'll also introduce new enhanced functionality of these processes, and because we're no longer supporting Hive, we hope to use the open source maintenance procedures and then also contribute to the open source with any enhancements. We're going to keep the Metacat API for legacy use cases. It's a widely used API at Netflix, but it will rely on the IRC as a source of truth as opposed to the other way around. And we'll completely remove Hive and HMS support from the warehouse. So in the longer term, once we have this built, we'll continue to evolve and improve this platform. We can support the newest Iceberg features as they become available. So variant types, vended credential refresh are some of the ones we're interested in. We'll integrate new engines and formats as needed, in particular to support new AI and ML use cases. We're designing a more sophisticated table optimization system. This should further reduce storage and compute costs and improve query performance. We'll continue to evolve events and the observability tools built on those. And then we'll just continue to enhance the IRC and table maintenance processes. And we're also going to add in a backup and restore system.
If you like where we are headed, we are hiring. That's okay. Okay, we'll be sticking around after the talk. If you have any questions about our Netflix IRC or jobs, we're happy to answer any of them. Thank you.